So thank you. No bad noises so far. So thanks for having me. I want to talk with you about, or give you a guide on how to ruin your personal cloud journey based on personal experiences. And at this point, you might maybe ask yourself, who's talking? So, hi, I'm Torsten Hopf, as the name and my perfect British accent say. I'm from Germany, and I'm working at Schwarz IT. Who does know the company Schwarz? Yeah, that's good. It's the biggest company in Germany, so great marketing. Has anybody of you ever heard of a company called Lidl? Yeah, probably, that's more. So Schwarz is the big company behind Lidl, Kaufland, and a lot of other companies. And I'm working at Schwarz IT, which is the software development group inside this company. And we are trying to fulfill critical business functionality with the development of software. Also, a few years ago, we started building our own cloud platform because, we are a bit weird and we are afraid that maybe one day, depending on who's the president, the US might plug the pull. So, and nowadays, I'm mostly coding in Go and TypeScript on that platforms, but I also have a really strong past and will always have Java will always have a special place in my heart. I'm using a lot of Docker. I have a past of AWS development, also a past of Azure development. And I'm also teaching C++ at the university because it's always good to do what you like in your free time. And I actually don't want to code C++ for money anymore. That's more like a scientific interest that I have in that language. But also talking a bit about who am I personally. I'm not just working, even if it may look like that. I'm definitely not a nerd, so don't be afraid. Example one, I would say I'm more a passionate but unsuccessful gamer. Example one for not being a nerd, I have 3 cats. And no nerds would have 3 cats, right? And they have the completely fine, unnerdy names, Ron, Hermione, and Harry. But another example, I have also 2 horses with unnerdy names, which are called Faramir and Eowyn. And sometimes in my free time, maybe a little bit nerdy, I also play D&D, so yeah. Okay, let's dig into that. So what are we going to do today? I want to take you on a journey. I've prepared 3 tales for you, which reflect some less successful parts of my cloud journey in the past. All these stories happened exactly like I'm telling you. And I'm pretty sure I'm not the only one going through this. So what I want to achieve with this talk is I want to obviously also entertain you a bit, which worked so far quite good. That is good. But I also want to give you arguments if you find yourself in similar discussions or situations. So let's start. Chapter 1, the myth of the 2 false starts. So the situation is as follows. We have a customer, which is always nice. And he's reading through some magazines and then thinks, hey, wouldn't it be great if I would also connect my machines to some central data store and then I can run analysis on it? Maybe something like this. Machine, Blackmagic, dashboard. Perfect. We'll do that. So he got into a conversation at a shady booth at a conference or something like that and gets these consultants and is asking them, hey, can you help me with some IIoT strategy? And they're like, yeah, sure thing. Nowadays, this stuff is realized in the cloud. Oh yeah, cloud. I heard about that. That's a good thing. Which provider should I choose? And what to do if you're looking for a cloud provider? Do a POC. The problem in this situation is neither the customer nor the consultants have any experience in the cloud so far. So what they did is they built 2 routes. One, have an on-site machine, an MQTT broker, bring it to IoT Hub, Data Lake Storage, Power BI Dashboard. So I guess from the names you can already guess the cloud provider. And then take another machine. Oh, there should be a machine number 2, but you get that. You're smart, I'm sure. And use Greengrass, IoT Core, IoT Sidewise, and Dashboard. And Route 1 works, Route 2 works, and now the big surprise. Both hyperscalers are actually able to collect MQTT messages and create dashboards. Wow. But how do we make a decision now? And yeah, so the story continues. So yeah, consultants say, hey, cool, both hyperscalers are comparable in pricing, they fulfill the requirements. And yeah, then the question is, which one is the right one for our company? The consultants say, yeah, let's just continue with the POC mode. We'll find out. And yeah, the right question is, what did I pay 70K euros for? I thought this is the POC. So then there was some back and forth. And that's the point where I got into the story out of nothing. Getting asked, hi Torsten, can you please create a slide which tells our customer who's the best hyperscaler out there? Thank you, bye, see you tomorrow. That's a hard task, and honestly, that's not really how it works in my experience, because you need to ask other questions. You cannot just say, yeah, AWS has the biggest service catalog, Azure has Office 365, I don't know. It's not working like that. There is not that one hyperscaler, except obviously stack it. Yeah, let's keep the facts right. So what I did was, I was asking the customer, pretty straightforward, which was really black magic for my other consultant colleagues. Could you please go to your head of IT and ask him if there are maybe already any other cloud initiatives in the company? And surprisingly, no one in the room before ever even thought about that option to ask someone from IT what the company is already doing. And surprise, surprise, turns out the whole company is running on Office 365. And the finance department is currently rolling out a BI solution based on Azure. So it's pretty easy for me to then say, going multi-cloud, we just heard it. It's adventurous, it's fun, but probably not if you actually want to get something running in the beginning and you're losing all the scaling effects. So I said, hey, if you made good experiences with Azure, maybe we continue on that way. And what were the results of this great project with the 2 starts? Well, the customer spent 70K pound. Oh, I had that wrong in the other slide, but was 70K pound of invest for 2 throwaway POCs. Not even if we would have chosen one of these solutions, we could have continued using them because there was no infrastructure as code, there was nothing. It was just all clicked together and some fancy Python scripts in between. And one actual question could have probably used that 70K to actually build one MVP, like one thing that he could use to sell to his stakeholders. Here, this is what we are building, this is working. But we won another 10 days to create a proper solution on how to do that stuff on Azure. And yeah, they took this design and let the guys that already built the BI solution for the financial department also build that IoT thing, which I can totally relate to. I also wouldn't have ordered another few €100,000 from us in this situation. So only good thing about it is at least everybody learned something about it, or well, at least I did learn something from that. So what's the moral of the story? Let's try it in a bit fancy way. A great adventure is only possible when a wise guide with a map and compass joins the fellowship. If you want to do a cloud project, get at least one person who has actually ever worked in a cloud environment. And whether you choose a magic bean or a golden egg, a simple spell works wonders in any kingdom, which means all hyperscalers will probably have solutions for what you are trying to achieve. unless you want to get trucks coming to your data center and totally take them all and ship them into another data center of the cloud provider or whatsoever. So if you're just doing basic stuff, all cloud providers will be happy to help you with that. And a wizard spell, no matter how clever, is worthless if only it creates illusions and no real matter. So whatever you're building, if you're at a point where you're building something that you for sure will throw away, think twice and think if there's other questions you can ask to actually create value, which is also the last thing. Yeah, before you build your grand castle, you must first survey the land to see what sleeping dragons already lie there, which is a really fancy way to say there rarely is a green field, and there will be organizational guidelines that properly move you towards a special direction. So, chapter 2, the song of the overeager novices. The situation is as follows. The times were dark, the nights grew longer, it was already October, it was all boring, daily business, common environment. But out of nothing, a gem popped up, which was an application to evaluate managers' leading behavior. Was requested really short term because they wanted to start with that beginning of January, which luckily means that the timelines were too short to wait for the typical enterprise server provisioning, getting some Tomcats and databases. That takes way too long for that. So it was a perfect opportunity for us to directly start moving to the cloud. And we pretty quickly find us in the situation where we also had to decide what to do. Do we try to do it like the modern, really fancy way that was during my AWS times, as you can see? Like going full serverless, having the front end deployed in S3 buckets, an API gateway with Lambda functions that go on serverless DynamoDB tables. Really modern, really fancy, but also really new for us. Or do we do it the old, proven, solid way, just using the cloud as infrastructure provider, having our robust Java Spring Boot app and Angular frontend on one server, maybe with a bit of Apache technologies on top of it, and hosting our database right next to it. And what should we do? How to decide in such a situation? Well, luckily there's help anywhere. You could just go on YouTube, watch some people explaining to you how to do that, what to do, what are important criteria to decide. You can go through reference architectures, and you can also use e-learning platforms like Pluralsight, LinkedIn Learning, whatsoever. Or you do it as in our case, we had a partnership with one cloud provider, and they were dedicated solution architects. And history is not really sure if we said it like this or if this is just what we got. But what we got was go serverless or go home. There's no better way to build your app. So that's what we wanted to do. But on the other hand, we were also a bit afraid of that. So we choose a hybrid approach. We kept our solid Java app on the server, hosted the front end on an S3 bucket serverlessly, really nice, and use DynamoDB tables to not have to worry about our server database server instances. So that was the first idea of how to build it. And reality shows that that's a good picture to explain what we are doing in general. But if you're really doing it, a lot of services come together. So we needed like auto-scaling groups, encryption keys. What's going on here? Oh, it's working again without doing something. I love that. You need load balancers. You need a cloud content delivery network. You need DNS routing, all connected to a certificate store, email services, CI/CD pipeline in the cloud, and so pretty fast. We were already using 7.5% of what AWS had to offer back then. But it was a great success, celebrations. we were able to somehow deliver this whole project in 2.5 months, bringing it to production. Like, that's the mindset. Ship it. Yeah. It was really cheap, to be honest. We used like some discounts. Our app server was really, really small. So we were able to run both stages for less than 200 euros a month, which was, yeah, quite surprisingly. And integration of that AWS services was much easier than expected, even without ChatGPT back then. Yeah. And there even was a JPA library for DynamoDB, which would have its, which would come to stage later in this talk. And yeah, overall the app performance was really great. It was so much faster than this on-prem Apache stuff. Response times of the front end were really good. I loved it. And so we were in a really good mood, just until day one with real users, sadly. Because while we were sitting there, still having a bit of hangover of the alcohol-free champagne that we drank, users and the customer started to complain about long loading times after each user interaction. Like, you have to imagine a form with a lot of things to press, and every time you do it, it takes first 100 milliseconds, then a second, 2 seconds, 5 seconds, timeout seconds. So yeah, we got into analysis mode and we're directly sure, yeah, it's because we were so cheap. The small app server is the problem. But sadly, we had to find out it's neither the CPU or the bad network of the AWS data center, but it was our database, or not really the database, but our database code that was maybe not optimized for the situation. And that led to really long loading times and timeouts by going over the provided read capacity and then leading to all requests being throttled until they get into immediate timeout. And we were promised that we could serve millions of user requests in the free tier with our 5 read capacities. But turns out that if you do a not perfect select statement or query, you will always do a full table scan, which you don't see because you have hidden that perfectly behind 3 layers of Spring, JPA, Java libraries. And what do you do now in such a situation? The thing is live, the workshops are already done. You cannot say, let's take it back, just do it manual again. There is luckily a magic button in most cloud providers, which is the auto-scaling. Just put it on and it will work. And that's actually what happened. Everything was perfect. The users were even writing us emails of how great the app is, and we were really happy again. Just until the end of the month this time. So I'll give you a quick overview of our cloud consumption. Do you have an idea where we put the auto-scaling on? Yeah, exactly. And I'm a really senior consultant, as you can see, but even I had to admit this is a small increase. And the guilty one, or guilty ones, were definitely DynamoDB and the developer in front of the PC. Yeah, so our heroes were totally desperate after this experience, questioning the whole career decisions that led to this point in their life. Why did they even think of going away from on-prem? It was all perfect back then. But luckily, we could fix our data model issues that caused the problem in a few night shifts for the next 2 weeks. And as most people that burned their hands, we went back to stuff that we know. We just migrated back to PostgreSDB. Maybe not as cool and fancy. Come on. Thank you. And maybe not as fancy, but it worked out for us. But it's really important. One thing that I really want to teach you is it's really important how you tell the story. I was now really honest with you. Maybe said that I did something wrong. But this is not a story about how hasty decisions led to unnecessary cost. This is actually a story about how intelligent architecture optimization can reduce your cloud consumption by 90%. So what's the moral of the story here? Even a failed experiment can, yield a treasure more valuable than gold. We learn best from our failures, not from our successes, which turned me into a real DynamoDB crack at our company afterwards, and I'm glad nobody ever asked how I learned all that stuff. And a wise leader encourages all his subjects to share their wisdom, for a shared map guides the entire kingdom to prosperity and prevents others from falling into the same trap. I guess we learned a lot about it yesterday. An open culture about, an open failure culture is crucial for success here. And when a kingdom decides to move its castle to a new floating island, the entire village must learn to navigate the winds and the clouds, especially the clouds. And moving to the cloud is a major technology shift. Sadly, all the stuff that you hoped you would never need to do again, like calculating subnet masks and IP addresses and IP ranges and whatsoever, it all comes back with the cloud. Thanks for that. And a great builder does not expect his masons to be master blacksmiths as well. For a single person cannot wield every tool. That turns more and more true every day. You cannot have that one AWS expert. I mean, we now have far more than 200 services. It's probably more 300 or I don't know, the granularity. Not even talking about Azure, Google Cloud, StackIt. You cannot be a pro in each domain. You need to have different people in the project that like to focus on different areas. Let's go to chapter 3, the tale of the never-ending cloud migration. Somebody knows what's happening. So we have a really, really experienced team, really heroes. They are taking care of their lovely application for years. They have a really high reputation throughout the whole company, and they are known as the team that gets it done. So we have a really basic diamond architecture, one load balancer, perfectly multiple app servers with Tomcats and Apaches on it, and one database. So the scaling is more a thing of the app servers, I guess. And now everything is perfect, so that's the right moment. The whole company wants to move towards the cloud until 2025. Still moving there, by the way. But so we are again at a hard decision. What do we do? Do we re-architect that whole thing? Or do we just do a lift and shift? What does that mean? Rebuilding the whole thing would guarantee best possible utilization of the cloud, which would mean we need to migrate the functionalities from our lovely Java app into serverless functions, probably rebuild CI/CD pipelines completely in the cloud, which would have pretty high ramp-up cost in beforehand. And it's really hard to do that while there's still nasty business features coming in. You want to focus on just the technical stuff. Or do a lift and shift, which is just rebuilding the whole thing that you have on-prem in the cloud. It's the least efficient runtime model in the cloud, but it's easy and fast. And you get your app there, and the theory or the marketing of the cloud provider say from there on it's much easier to do all the next steps. But you will also need a longer phase of optimization afterwards to not just pay thousands of euros for your lovely, EC2 instances, Kubernetes clusters, whatsoever. So this team chose an approach which is named like the Strangler approach to combine the cloud migration with the daily business. So new features get developed cloud first. They keep the service as is in the beginning. They choose to move the database to the cloud first, because the SLAs were running out for the on-prem databases. Then they wanted to just move the front end into S3, and then re-platform the back end. How hard can it be? Containerize it, Docker, ECS, throw up, and then shut off the on-prem servers, all good. Which is a nice plan, but it would be a shame if someone would cut a budget right in the middle of this transition, right? So how's the execution of that going? So we have the browser of the client, a workshop worker in this case actually. And yeah, we have already moved to the cloud some serverless features behind an API gateway. We already moved the front end to S3. But we are also still using our on-prem front end because we are not yet 100% sure how this will all interact then. And we migrated the database already. And now we get stuck somehow in this phase because the source of magic drains somehow as the numbers are getting worse on the business side. So there's no money anymore for non-business relevant topics. Who needs this who wanted to do this cloud transformation even, yeah? Nobody needs that. So new topics, do it wherever you want. We don't care, but the migration of the rest is deprioritized because it's running totally fine, isn't it, on the on-prem servers. So what do you get from it? It's simplified, really simplified. You have backend code, front-end code hosted on GitLab, pipelines to build that, push it on an internal Artifactory, have a magic deployment tool which takes the artifacts and places them on the on-prem servers. Great, works for years now. But now you also have infrastructure as code that also wants to be built somewhere. You have function as a service code or Lambda functions in this case, code that also needs to be built, deployed to the cloud Artifactory. There's small deployment jobs in another language, obviously, that then push that into the cloud. And you get the complexity grows and grows and grows. You go more and more polyglot, and it's really hard to maintain. It gets instable. The instability is rising. The deployments got flaky again. Yeah, back then you could just let the intern do the deployment while everybody else was out for lunch. Now each prod deployment takes 3 hours and needs some rollbacks in between. I don't know if you've ever worked with CDK in the room. But yeah, it more feels like a beta sometimes. Works fine for 2 stages, 3rd stage, don't talk about that. So pretty fast, the maintenance burn all the saved money. And so you get really a lot of open fires that the team needs to take care of. And the time spent on updating, fixing, working around these processes, it quickly exceeds the investment that you would have needed to just re-platform the app. And by that, and one stable and easy to deploy app turns into a flaky mess. So the moral of the story here is that a wise architect plans for temporary bridges. I will accelerate a bit. It's absolutely right to develop transition architectures for the shift into the cloud. At the same time, it's you really need to make sure that these transition architectures are used for transition phases. We are talking here, they accepted all of this for a time span of 7 months. But we are now at year 3 of this state, and it gets worse every day. And it's really important to have the business buy-in, because if you have a lack of commitment there, you will get your topics deprioritized. And I know in many companies, business is the one that gives the money for IT. So you need to show them measurable advantages and clearly communicate these, because there is value in going to the cloud, but you need to make everybody in the room understand it. So the epilogue, the story continues. The party finally reached their goal. Everything is deployed to the cloud. The crunch and hard times are over. They can finally celebrate their success, enjoy all the gray hair they moved on they're grown on their mission. And now they can go back to feature development, right? Without caring too much about the cloud transformation. Well, a new dark power is already arising. We have disaster recovery in the cloud. The number 1 disaster that happens is not infrastructure outage, by the way. It's the company's credit card not being valid anymore, where all the other accounts are hanging under. True story here. Key cert rotation needs to be done, mostly pretty manual for such a basic tasks. The biggest foe, FinOps, optimizing the cloud consumption that you have by reducing server capacity, scale down, whatever. Dependencies get an even worse topic. A lot of updates to do, not only on front end, back end, but also infrastructure as code libraries. The cloud providers tend to spice up their SDKs quite often as well. And you are on the constant attack. Like 40% of the calls we had to our environment were just port scannings, DDoS attacks, injection tries to find like the log4j queries and whatsoever. So yeah, that's really scary if you take a look at your dashboards. So back to ARMS. The work is never done. The world sadly got more complex with the cloud. It will never get simple again. It was never more challenging to be a developer, but for me, it also never was more fun, because finally, if I want to deploy a new service, I just can do it. I don't have to ask, hey, IT, do I get another container or host or whatsoever? So yeah, the amount of possibilities is virtually endless, but there's also a lot of new ways to fuck up. And there's one thing that doesn't change with the cloud. So I hereby promise to you, wonderful people of London, that by my honor as a software engineer, I will try to find all these ways to fuck up, and that I want to talk about every single one of them. And with that, I can just say thank you for your attention, and let's move questions probably to the coffee break. Thank you.